Well, good morning. How are we all doing today? Hopefully you're able to see me okay, and hopefully you're able to hear me okay. I'm looking at all of my monitoring things, and you ought to be able to hear me just fine. So do feel free to say hi in the chat and let me know that this is working. Okay, we've got some positive indications in the chat, so fantastic. So yes, welcome back to Engineering 1020, and here we are in Lecture 3. You may have noticed, by the way, that these lectures aren't numbered starting from 1. They're numbered starting from 0. I wonder why that might be. Well, we'll come back to that as we get a little bit further in the course. But that is something that is actually a pretty common convention in programming languages. And for reasons that will become apparent as we go through the course. Okay, let me start out by asking you just a quick little question, which hopefully this one will be very quick in Top Hat. Look at that. I apparently didn't do that thing that I thought that I did and putting Top Hat into the background. All right. There we go. So you should be able to see this question now. Hopefully this one will be super duper quick. Hopefully people are able to see that question in Top Hat. All right. I see one answer coming in, so I guess that you are able to see it somewhat. All right. While people are answering that question, which part of a computer executes instruction? Is it CPU, I/O, or memory? I will just mention that exercise 1 is available for you to complete. Exercise 1 is described on the course webpage, and so you need to do a little bit of reading to try to understand the problem. And is very common in a lot of programming problem solving, the first thing we need to do is understand the problem without any programming. So in this case, there's a little bit of mathematics that describes some things that are relevant to structural engineering. And so you're going to look at a couple of equations and things, and then you're going to figure out, okay, at the end of this exercise, I've asked you to write a Python expression. So an expression, not an equation, just an expression, something that evaluates to a value. A Python expression for load on a cantilever under uniform loading. Now, what is a cantilever and what does it mean for it to be under uniform loading? Well, that's where you're going to do some of this reading. And none of this has to do with programming, but it has to do with problem solving. So that's where we're putting our problem solving hats on. And you're going to have to figure out, first of all, and this is, again, often a common pattern, you're going to figure out how would I solve this problem without programming. So in this case, instead of finding a Python expression for something, what would be the mathematical expression for the load on a cantilever under uniform loading? And then, once you have that mathematical expression, that's kind of the hard part. That's the intellectual heavy lifting. Then there's just kind of an almost mechanical process of translating that mathematical solution into a programming expression. So if, for example, you determined that, sorry, I meant to be showing you my screen while we were doing all this. By the time we get back into a classroom, I'll have really, really mastered this whole YouTube streaming thing. So you have to do some reading up here, and then we come down to the expression. And so this Python expression that I want you to write, well, first figure out a mathematical expression. Then say you figure out that the mathematical expression for the load under cantilever, whatever, is angle divided by x. Now it's not, but let's say that it were the angle divided by x. Well, what would we do then? Well, if we flip over here to, there we go. Now you can see some code as well. The expression that I would expect you to write in that case would be something like angle slash x. Now, a couple of people have encountered issues in exercise 0 trying to figure out how to submit something that is valid Python. And actually, that's kind of mainly the point of exercise 0 is to make sure that we can figure out the tools that we're going to use to do work and to submit work. So you should note, and this is true in Thonny, but it's true in lots of other IDEs. It's true in some of the online ones as well. Very often there are two places that you could type a Python expression. So in Thonny, down here we can write an expression like 2 times 3 and press enter. The fact that you see here it says Python and a version number, and then it gives you this little prompt and says, hey, I want you to type something, and you type something. This is a Python interpreter. So this is an interactive conversation that I'm having with a piece of software that runs Python. The other way that we can, and this is the thing that you need to do for an exercise or for an assignment, the other way that we can write Python and complete the assignment or the exercise is in the top part here, or it might be in a different part of the window depending on what program you're using. But for Thonny, up here we could write something like 2 times 3. And that is, if we then hit save, this will take whatever the contents of this box are and save it to a Python file. So I could click save and then say save that as exercise0.py or something like that. So we have the interpreter that we can use for kind of playing with Python, talking to Python, interacting with Python, figuring out how these expressions work. And then once we've got an answer that we're happy with, then we can put it into this box and save that as a Python file. That was the approach in assignment 0 or exercise 0, and that's the approach in exercise 1. And once again, the exercises, feel free to work on them together. They are not individual only work. The assignments will be individual work. So before we get to the assignments, it would be really good if we all had a nice strong handle on how to complete and upload exercises. So for exercise 1, in which you have different values that you might use. So if you wanted to write an expression, it could be something like angle divided by x. Save that as exercise1.py, upload it, and then Gradescope will tell you, okay, I've tried this value of angle and x and L and all these different variables that are given. I've tried putting these values into your expression, and it gives the right answer or gives the wrong answer. And then there's a bunch of different test cases and says, I tried with these values, you got the right answer. I tried with these values, you got the wrong answer, etc. If you find that there's a wrong answer, then that might mean you need to go back and revisit your mathematical expression. Or it may mean that the mathematical expression is right, and you can check it yourself. You can say, well, if I take those values and plug them into my mathematical expression, do I get the right answer? And if you do, then maybe that means that the problem is in translating your mathematical expression to the Python expression. Something like, oops, I used the wrong division operator, or oops, I said exponentiation instead of multiplication, or something. So let's see. There's a question. Should we set a value for the variables? Yeah. So if you want to test things out in the Python interpreter and try to run your expression and see what the result is, you can provide a value for some of these variables. Now, we're not going to get too much into variables until Friday, but just for today, I'll say that if you want to have a variable that is already defined in your Python interpreter, value x, and that's equal to 12, you can write x equals 12. And in this case, I might say I'll set the length of the beam to be 24, and I'll set my angle to be equal to 0.5 radians or something like that. And now I can use those variables in my expression. So like angle divided by x, and it'll tell me what the answer is. L times x divided by L times angle, and that'll tell me that number is 0.25. So that's a way that you can kind of take your expression and check it yourself without having to upload it to Gradescope. Or alternatively, if you get something from Gradescope that said, I tried the value angle being this, and x being this, and L being that, and you gave me the answer this, but it should have been that, well, then you can plug those values in yourself here. Will there still be unlimited submissions allowed for this exercise? Yes. So I'm going to set up all of the exercises and, in fact, the assignments in this course to allow you to resubmit as many times as you would like. Once we get to the assignments, I may have some test values that only become visible after the deadline, but you'll have a good number to look at, and that should help you catch any obvious issues. And then you'll be able to resubmit and resubmit and resubmit all the way up to the deadline. Is the question what executes the instruction in a computer? Yes, so the top hat question that is still percolating in the background is what part of a computer executes instruction. But there was a question here, will anything written in the bottom box be saved in a submission? No. So this interpreter is something that I can use to have a live conversation, and nothing gets saved. It's kind of like if you came to my office and we chatted and you asked me questions and I gave you answers and vice versa, then that's kind of like me typing in, okay, well, what is the answer of 21 plus 21? And Python tells me something, but there's no record being kept here. This is a little bit more like a letter. So you write a letter to me and send it to me. Well, now we have a record of it. So up here, this is like writing a letter, and this is like having a conversation. Sometimes an interactive conversation is the quickest, easiest, best way to do something. Sometimes we want to have a record of what we did. So that's kind of the distinction between the two. Okay, so yeah, let's go back then to this top hat question. Which part of a computer executes instructions? And I am anticipating that there'll be a high percentage of students who gave the correct answer, and yes, indeed. So memory stores information, the CPU executes instructions, and I/O peripherals are used to interact with the outside world, which can include the user. Okay, so let us then start talking about some new things. So last time we were talking about expressions, and in this lecture we will talk about some more kinds of expressions. So what did we say an expression was? What is an expression? In mathematics or in programming? Several people typing. That's good. Right, so an expression is something that evaluates to a value. That's right. So an expression is a collection of values and operations that evaluate to a value. So we have seen several types of values, and those included literals. And we had different types of literals. So there are integer literals, floating point literals used to represent real numbers, string literals. What do we put around string literals to tell Python, hey, this word hello doesn't mean a variable called hello. It means the string that contains the characters hello. What do we put around them? Quotation marks, right. Single quotes or double quotes. And so we had integer literals, floating point literals, string literals, and Boolean literals or logical literals. So those are true or false values. So we had literals and we had variables. Yes, and people are giving me in the chat different forms of the so sometimes you can use 3 double quotes or 3 single quotes. So there's lots of different ways to do quoting. So we have literals and we have variables. And thus far in the course, we're just using variables. We're not really defining variables. We'll get to that on Friday to talk about some of the differences between math variables and Python variables. But using variables is something that you have to do in exercise 1. You have to write an expression that includes arithmetic operators and that uses variables, but those variables have already been defined for you. You don't need to define them. You should just submit an expression. Just like in exercise 0, I asked you to submit an expression that evaluates to 42. That could have been just the number 42, or it could have been 1 plus 1 plus 1 plus 1 all the way up to 42 or whatever, but just an expression. No equal signs, no anything else, just an expression. Okay, so we saw values and we saw some operations. So expressions are values and operations that evaluate to a value. Well, here are some operations. So we saw arithmetic operators, and that included addition and subtraction and multiplication and division, both kinds. Both kinds? What in the world do I mean by both kinds? And somebody can answer that in the chat while I also say that we also looked at exponentiation. So what in the world did I mean by both kinds of division? Well, let me pop this question up for you. Yeah, okay. So in the chat we had sometimes we can exclude a remainder or include a remainder. Yeah, that's an okay way to think about it. So there are different kinds of division operators depending on if we're dividing integers, what we want to do about remainders versus getting a floating point result. All right. Since I am going to open these questions after the fact for people to answer as homework, I'm not going to wait around too long for people to answer them, but certainly do drop an answer in there now in the next kind of few seconds. And let's see. I'm going to count down from 5 and click closed, and then we'll see how long it takes for it to be closed at your end, or if it closes on your end before I get to 0, and that'll be another measure of latency. So 5, 4, 3, 2, 1, 0. Okay. I wonder what number it seemed to close for you. All right. And so indeed, yeah, almost everybody had the right answer, which is that 7, mathematical division operator 2, 7 divided by 2 is indeed 3.5. Okay, so that is fine. Oh, wow, 5. Interesting. Okay, for some people it closed on 3. Okay. How about this to review what we learned about division? So now we're talking about a Python expression, 11/3. What will that evaluate to? All right, answers are coming in. That's great. All right, I'll close this out in another 5 seconds or so. All right. And again, it will be available as homework. And okay, and here we said most people had an answer somewhere in the range of 3.6333 to 3.7067. So that should be right, because that ought to be about 3.6667, I believe. And we can just check that in our interactive Python interpreter. 11 divided by 3, yeah, 3.6666. Oh, interesting. Here it ends with 6665 instead of 6667. So that would actually round down once you get to a gazillion significant digits. So that's kind of interesting. But again, as we saw, computers can accumulate small amounts of errors. Finally, however, I'll ask you another thing about integer division, which is... Okay, what does this Python expression evaluate to? Someone's saying the questions are not appearing on my screen for some reason. So I think it's set so that the question won't appear on your screen, but the place to provide the answer will. I believe that's the way it ought to look. If that's not how it looks for people, then you could let me know that in the chat. I'd be... Now, I don't see the same thing that you see, so I would be very interested to know if my understanding of how the questions are appearing is incorrect. It only let me answer numerically. I can't use R. Yep, that's true. That is true. So this Python expression... 11/3, what does that evaluate to? And it will indeed be a number. A number will be the correct answer. All right, so let's close this and see what people had to say. All right, okay, so yeah, there's no flies on you folks. Almost everybody said indeed correctly that 11//3 gives us the integer division of 11 divided by 3. If we want that remainder, then we use a different division operator, which is the percent sign, which means modulus. So remember last time we saw 3 different division operators. There was a single slash, a double slash, and a percent sign. Those are the 3 division operators. So we have both kinds of division, either floating point addition or integer division. Good. Okay, so yeah, we saw addition, subtraction, multiplication, division, exponentiation. Today, we're going to talk about some more operators. So we've seen literals and variables, some arithmetic operators. Today, we'll talk about comparators and logical operators, and we'll talk about function calls. And that'll round out what we need to talk about with expressions to let us get started on a pretty solid basis, where by the end of today, you should be able to do a bunch of more things in Python than you could have done at the beginning of the class. We kind of move quickly at the beginning of the course, which is kind of exciting. Okay, so comparators. What are comparators? Well, comparators are something that you use all the time. Whenever we describe things as either being equal to each other or not equal to each other, these are comparators. Now, in mathematics, if I were to write... So let's see, today I'm going to use our whiteboard for the first time. So in mathematics, if I were to write that 3 is less than 4, okay, that's fine and hopefully kind of uncontroversial. If I wrote that 3 is less than x, well, that's hopefully not uncontroversial, but what is that saying? Well, that's saying that 3 is less than x, so alternatively, we're saying that x is greater than 3. But suppose I said 3 is greater than 4. What happens there? Well, clearly this is a logical contradiction that could unravel the fabric of space-time itself, and so the universe will like unravel itself and vanish in a puff of logic. Or as Doc Brown said in the classic time travel movie Back to the Future, admittedly that's a worst case scenario. The destruction could be limited to our own galaxy. Okay, so I wrote 3 is greater than 4, and clearly the world didn't explode, but this is not like a valid thing to write down in mathematics, right? This is invalid. In programming, however, it is not invalid to write 3 is greater than 4. If I press enter, the universe isn't going to explode. Nothing is going to, there'll be no consequences raining down from the skies. Instead, we need to realize that comparators, as we use them in program, are not statements about what is true. They are expressions. So they are things that can evaluate to true or false. So the expression 3 is greater than 4, what's that going to evaluate to? Well, someone said in the chat, which is good, that is going to evaluate to false, because that is incorrect. 3 is not greater than 4. If I said 3 is less than 4, well, then that evaluates to true. And that's going to be really, really important, understanding that comparators here are expressions and not statements of fact. That is going to be really important when we start doing things like making decisions based on comparators. If something is greater than this, if the temperature is greater than 20 degrees, then turn on the air conditioning. Once we start doing that kind of thing, we're going to need to understand that we have expressions that could evaluate to true or could evaluate to false. So let's see, in the slide we have less than, we have greater than. Less than or equal to in most programming languages is written with less than sign next to an equals sign. So instead of the nice fancy mathematical way of writing a less than with a little line under it, so it kind of looks like a less than and it kind of looks like an equal sign, instead we're going to write 3, a less than sign and an equal sign. Greater than or equal to works the same way. And also, when we want to test whether two things are equal to each other. When we want to write an expression with a logical comparator that confirms whether or not the thing on the left-hand side and the thing on the right-hand side are equal to one another, we use two equal signs and not one. And at the moment, well, we haven't seen why we would use a single equal sign, but it's important. And so the distinction between a single equal sign and two equal signs is quite important. So here I'm going to check, is 3 equal to 4? And no, it's not. Not equals, we don't have a way to write a slash through an equals sign with the keyboard. Well, the Unicode alphabet now, so we'll talk more about the origins of why strings are represented the way they are and how some of the early computing stuff was done basically in the United States, and therefore not a lot of thought was given to representing languages other than English, which was kind of unfortunate. That's changing, and so computers, and Python in particular, are getting much, much better about allowing everybody to write in their own language. But still, a lot of the core language functionality assumes that we don't have a keyboard that lets us type really fancy things like mathematical symbols. So 3 not equal 4 is 3 exclamation equals 4. And that's kind of like an equals with a stroke through it. Okay, so those are our mathematical comparators, and they evaluate to either true or false. All right. We've got exclamation marks being reacted to something. I'm not sure if it's to the word false or to the fact that people didn't really upfront think that anybody who uses languages other than English might like to use computers. When you say it that way, it's kind of a ridiculous assumption, but it's really easy to get caught up in your own little world and not think about the people outside of your own little world, and therefore make assumptions about who's going to use the technology, how, and why. Which is a very important lesson for engineers to learn as we are designing technology that may be used by many, many people in the world, and we shouldn't assume that everybody who uses the technology looks like us or thinks like you or wants to use the technology for the same reasons as you. Okay, let's see. Let me... No, let's leave this alone for now. Okay. Actually, yeah, we'll leave this alone. Sorry. Trying to decide whether to ask that question now or ask it later. And I'll ask it later. So comparators are one important kind of logical operator. And then there's the explicit logical operators that work on, instead of comparing, is this number greater than this other number? Instead, logical operators work on Boolean values. So they have Boolean operands and Boolean results. So let's see. So this, first of all, where is the operator in what I'm showing you on the whiteboard currently? Or what is the operator? In this expression, there are three things. Right, the greater than. So we have, this is the operator. And then we have, actually I should write it out, because what do we call 3 and 4 here? Those are called operands. So they are the things being operated on by the operator. And how many operands does the greater than operator have? Or how many operands does it operate on? And it's going to sound pretty obvious, right? Yeah, 2. So this is something that we will call a binary operator. And there are lots and lots of binary operators. If I write 1 plus 1, well, plus can often be a binary operator. If I have 2 minus 3, well, in that case, minus is, in this case, a binary operator. There are lots of binary operators in the world. And some of those binary operators are operators that have logical operands. So instead of numbers, in this case, they're true and false values. And the operators that we're going to think about, the logical operators that we're going to think about are and, or, exclusive or, and not. Okay, so and or kind of have pretty clear meanings. So this fella, George Boole, helped us by explicitly codifying some of those meanings, but it's kind of obvious. If I say, I'm going to have a nice day if I got a good amount of sleep last night and the weather is nice outside, well, let me tell you, I did not get a good amount of sleep last night. Finally managed to get to sleep, and then one of the kids wakes up, and anyway, so it was not a great night's sleep. So it doesn't matter what the weather is like, because that expression, good sleep and good weather, that is going to be false, because an AND operator evaluates to true if both of its operands are true. So if let's see. So true and true will evaluate to true. Boole is the goat. Nice. Yeah. It's pretty cool to have, something like that named after you. Although when I was doing my PhD, I was very excited because I was like, wow, I can't believe I'm doing my PhD in the department where somebody invented the subroutine. And then a friend of mine who was doing a master's degree in mathematics was like, John, I'm doing my math degree in the department where the equals sign was invented. I'm like, okay, fine. You win. And yeah, Cambridge is a special place. So true and true is true. True and false is false. If I say two things need to happen, this has to happen and that has to happen. If either of them doesn't happen, then the thing doesn't happen. So and evaluates to true if both operands are true. Or evaluates to true if at least one of the operands are true. If I said, you know what, it'll be a nice day if I had good sleep or if I have coffee, and I do have coffee. In that case, if I had bad sleep, but I have coffee, then if I say it's a nice day as long as one of those two is met, then okay, that's fine. False or true evaluates to true. True or false evaluates to true. What about true or true? If I say it'll be a nice day if I have good sleep or if I have coffee, is it a nice day if I have both? Well, I suppose it depends on whether or not you like coffee, but from my perspective, yes, that would indeed be a fine day. So if I have both sleep and coffee, great. So the AND operator, and I'm going to get you to, on the next slide here, I have a little table that I want you to take home and fill out, kind of this little piece of homework, where if I say we've got operands A and B, which can be true or false, I want you to fill out, okay, if A is false and B is false, what is A and B? What is A or B? And what are all these different operators? So I want you to fill out this thing called a truth table, which is what are the true and false values for all of these different logical expressions, A and B, A or B, A exclusive or B, and not A. But when you do that, you can use the Python interpreter to help you if you like. I mean, do think about it yourself and say, okay, logically, does this make sense? If this is true and that thing is true, then what should the result of the whole thing be? And do that for and do that for or. And when you use those, you're going to find that and or are kind of the natural uses of the word. There's not a lot of complexity to them. But the exclusive or is something that's a little bit different. And the exclusive or turns out to be really, really important in computing. The exclusive or says that if this thing is true or that thing is true, but not both, then an expression will evaluate to true. So the exclusive or operation will evaluate to true if exactly one of its operands is true. This turns out to be really important in computing for a bunch of reasons, one of which is that it's really easy to build exclusive OR operations in hardware. And also there are many, many things in computing where we care about kind of exclusive categories. Either this thing is this or it's that, but it can't possibly be both. So the exclusive OR matters a lot. But those three are all still binary operators. They have two operands, A and B, P and Q, have sleep and have coffee. These are all binary operators. Not is a unary operator. So that means it's an operator that takes one operand. Now, can you think of an example of a unary operator from like the arithmetic operators? It's an example of a unary operator. So here I will write down a binary operation, 2 minus 3. So someone said power. So power is actually also binary because it's something like x to the power of y. Well, that has two operands, right? There is a base and an exponent. So that is actually still binary. But we have a couple of things here. Right, so squared, yeah, that's still, it's a base to the power of 2. So there's still two operands. Right, okay, positive or negative. Factorial, good. So I said 2 minus 3 is a binary operator, but 2 minus 3 is not the only way we could use minus 3, right? We could just have minus 3 by itself. And in that case, negative 3, so we have a negative operator, which has one operand. And other people have pointed out other ones, such as like 3 factorial, or I guess the square root of 9. So the square root operator is unary. Now there's also an nth root operator. So if I said what is the nth root of 9, then that would be binary. But yep. So yeah, we've got some good examples there. And so just in the same way, we can say negative 3 is a unary, or the negative in that case is a unary operator. We can also have in a logical operation not p. So this is the way you write it in kind of mathematical notation. The way we write it in Python is a little clearer than the mathematical notation. You'll be glad to know if I have a value that is true, I could say not true. And that just gives me the negation of whatever the value is. So not true is false, not false is true. All right, good. Excellent. Oops. Meant to press F3 over here, not over there. Okay, so this is the little bit of homework that I'd like you to do to fill out this truth table. Say if A is false and B is false, what is A and B? What is A or B? What is A exclusive or B? And what is not A? So those are logical operations. We're going to be using logical operations a lot in the course. Okay, so then the other kind of expression that we're going to talk about today is function calls. So function calls are, functions are really important, and we will a little bit later in the course, not too far down the road, we're going to learn how to write functions, how to create functions. But for now, we're just going to worry about how to use functions, how to call functions, how to use functions that other people have written. And first, here's a question for you, and just type the answer in the chat. What are mathematical functions? Oh, there's a question. Why is an exponent binary and a square root not? So an exponent has two operands. There's the base and the exponent. So if you say b to the power of e, the operands are b and e. The binary, or sorry, the root analog of that would be the nth root operator. So what is the fourth root of 12? Well, the operands are 4 and 12. If you have just the square root operator, I mean, I guess you could argue that it is just the regular nth root operator, but you're implicitly having a 2 there, or other people would say that a square root operator is its own thing, and so it is a unary operator because it only has one. When you think about an operator, ask yourself, how many places are there where I could plug in a value? And that'll tell you whether it's binary or unary. Okay, so a function is something that gives an output when an input is given, right? So that's a good programming definition for a function, but in mathematics, things are a little more complicated than that. So we have a function like the sine function, and we can definitely plug a number into the sine function and get an output from it. But we can actually do more than that with mathematical functions. We can kind of break them apart and reorganize and solve for this and that and all kinds of funny things. Right, so mathematical functions describe relationships. Yes, they describe relationships between things. And there's suggestions of independent and dependent variables, and that's getting pretty close to the mark, although I will say I'm not a pure mathematician, and so I'm not going to go any further because a pure mathematician would probably tell me that I'm very wrong if I go any further than this and try to be more descriptive. But functions are definitely about relationships between domains and ranges. That's as far as I'll go. In programming, we're going to see that we are much more restricted in our view of what a function is. Now, there is a whole lot of overlap. And if you're already thinking of a function as something you plug a value into to get a result out of, then congratulations, you're already thinking about functions in a programming kind of way. Calling a function in Python looks an awful lot like, using a function in Python is called calling it, and that looks an awful lot like mathematical syntax that we're already familiar with. So once again, there's not a lot of sort of magic incantations in this course, but this is one that we're using up front from math import star. That will make a bunch of mathematical functions and variables available for us. And previously we saw that like the number pi is available, and also tau is there, which is just 2 pi. But also there are a bunch of mathematical functions such as the sine function. So if we want to find what is the sine of 0, well, it tells us it's 0.0. If we want to say what is the sine of pi, it gives us a number that is very, very close to 0. But again, notice it's not quite exactly 0, because whenever we use floating point numbers, tiny little errors occur, and those can accumulate over time, but we get a very, very small number. How do you get access to the conversation in programming rather than the letter? Right, so if you want to have kind of that interactive engagement with the Python interpreter, so in Thonny, that's at the bottom of the window, and you see it's a shell, REPL it, languages, Python 3, I think. Right, so if you go to REPL.it, which is a website, you'll see there are 2 windows. Over here, there's a place where we could write a Python script, which is kind of like the letter. And over here, you see, hey, this is telling me it's Python 3.8.2, and it's giving me a little prompt saying, type something, please. And that is the interpreter. So that is the interactive engagement that we can have. Okay. Right, so functions are called with syntax that looks an awful lot like mathematical syntax. The name of the function, open parentheses, and then arguments. There can be just one argument, or none in some cases, or there can be a bunch. So this is one area, however, in which math and programming start to diverge. Another really important, small but important way that they diverge is in how they work with variables. And that's why I said let's not worry too much today about how we create variables. We'll talk more about that on Friday. So functions in programming are kind of like math functions, but they're also kind of not. So you may remember this relation, this equation. Does that look familiar to anyone? Perhaps it does. So this is definition, or this is a mathematical identity, I guess. Yeah, okay, good. That looks familiar to some at least. So if I tell you this is a mathematical identity, and then I give you, here is a mathematical, here's an equation. Can we simplify f of t? So f of t here is a function, and then we've got some stuff on the right. And so if we were doing this in math, then yes, we could. We could take the j sine t over 2 plus cos of t over 2. We could pull those out and we could substitute in something else and say, here's another definition of f of t. So we can take what's in kind of inside of a function and pull some bits out and put other bits in, and we can do all kinds of cool stuff in mathematics, but not in programming. In programming, we need to think about functions the way somebody described it in the chat just a minute ago. It's like a machine that you put input into and you get output out of. So we have a machine called cos, and if you put a value of x in, it will tell you what the cosine of x is. So if we put the value of 0 into x, then we will get an output, which is 1. If we put the value 0.5 into x, into the x parameter, as we'll see they're called later. So if we put an input of 0.5 into cos of x, then we'll get an output of 0.87758, which is the square root of 2 over 2, but we just see it as a number. It's just a real number. Let's see. Someone said, your favorite equation. No. My favorite equation is e to the j pi is equal to -1. That's my favorite. But, that's a pretty good one, too. That equation hurts my brain at 11:45. Well, I'm just glad that this isn't... I think it's Engineering 1040 where the lectures are at 8 a.m. I'm glad that we don't have to do that. Okay, so we have a function is like a machine. You put an input in, you get an output out. You can have multiple inputs. You can have more than one thing that you put into the function. Later we'll see, actually, you can also have multiple outputs, but we're not going to think about that just yet. So if you had a function called f, that expects a value of x and a value of y, and you want to put the numbers 1 and 2 in for x and y, and f gave you a result of 1, well then in Python it would look kind of like the math. F, open parenthesis, 1 comma 2, close parenthesis. So whenever you see parentheses being used in this way, a function is being called. Whenever you have a function, in order to call it, in order to make it work, not just say there is a function called f, but make the function f do its job, you have to use parentheses. You put arguments inside the parentheses. So you're saying, dear function f, here are your inputs. Now kind of push the button on the side and it goes chunk, 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 think, work. And after a minute or so, out pops the result. Except instead of after a minute or so, it's more like after a few milliseconds. So later in the course, we will talk about how to create functions, but right now we're just going to talk about how we use functions. And there are some functions that we can use right now in order to help us kind of make sense of the world. So an example is there is a function called help. Well, that sounds kind of nice. What does the help function do? Well, we can type help and then give it the name of a function. So earlier we talked about the sine function, so I could say help and then pass it a function, which is the sine function, and it will give us information about that function. It will say, okay, the function sine from module math, it returns the sine of x. If I want to know, so there are other kinds of trigonometric functions that we got from math import star. They include things like a cos and a tan. So let's ask for help on a cos. What is a cos? Well, it returns the arc cosine measured in radians of x. And note also when we look at help for sine, it's measured in radians. So there are trigonometric functions that could be quite helpful. There's some other there are lots of mathematical functions in the math module, but here are some ones that might actually be useful and relevant to you kind of very soon, maybe even right now. A function like the floor function or ceiling. So the floor function and the ceiling function find the next highest integer or the next lowest integer. So the floor of 4.5 is 4. The ceiling of 4.5 is 5. Sometimes this is helpful. Degrees and radians. So 90 degrees can be expressed as 1.57096, etc., in radians. Or alternatively, if we had an angle in radians, we could say, what is that in degrees? So degrees of 3.1415926 is 179.9999999. So that's pretty close to 180. There's the factorial function, greatest common multiple, least common multiplier, etc. And so with these different mathematical functions that exist that we have now, you could actually take the opportunity, and this is, I really, really encourage you to see if you can do this. When you're doing assignments or exercises or whatever for other Engineering 1 courses, math courses, physics courses, chemistry courses or whatever, if you have to solve something and you have to calculate a quantity by hand in chemistry, in stoichiometry, or I don't know, try also writing that expression as a Python expression. And you can use that to sort of check your work, right? You do something by hand and then you let the computer do it and you see if you get the same answer. And that way, every problem that you get in those other courses, you're actually using to get benefit twice. You're getting benefit in physics and you're getting benefit in programming, and you're practicing both, and you don't have to spend a whole lot of extra time. So you're getting more value out of each question. So, try doing that kind of thing. Someone says, what is floor and ceiling? So floor and ceiling ceiling is the next integer above a number, and floor is the next integer below a number. So if you have a number like 4.5, then its ceiling, integer ceiling, is 5, and its floor is 4. So it's a way of kind of rounding, but instead of rounding to the nearest integer, it's saying where if I have to round, I always want to round up, or I always want to round down. Someone said, doesn't exercise 1 deal with the concept of function as well? No, just expressions. You'll need operators, you'll need arithmetic operators, multiplication, probably exponentiation. You'll need some things like that. I don't believe that you'll need any functions in exercise 1. And then, having learned about some more operators, there's more precedence rules. So before we said it's kind of parentheses, multiplicative operators, and additive operators. Well, now we see we have parentheses are still first, just like math. If you put parentheses around an expression, you compute that first. Parentheses, then there's function calls, then kind of like math, exponentiation, unary, multiplicative, and additive operations. Then the logical operators come after that. So comparison, not, and, or. Let me ask you a question now. Actually, you know what? I'll assign this question as homework so that you can think about it over the coming days. Because, and if you really want all the details about operator precedence, they are available in the Python language reference. However, it includes a bunch of things that we haven't learned about yet. So, I mean, if you're really curious, by all means dive in, but you don't have to. And you might find it slightly overwhelming when you start seeing a bunch of syntax for things that we haven't learned about yet. Okay, so that is time for our lecture, but I see that there's at least one question in the chat, so I'm happy to stick around for another second and answer that. And if any other questions come in, I can stick around for another couple of minutes before I have to go off to another meeting. I didn't understand on Monday how 7 modulo 2 yielded 1. Could you please explain it? Yes, absolutely. Be very, very happy to. So let's use a slightly bigger number just to make the process clear. So if we are going to say, well, what is 90? Oh, no, not 99. That would divide evenly. That's a bad idea. 100 divided by 3. Okay, so what's 100 divided by 3 using integer math? Well, 3 doesn't go into 1 at all. Okay, so that's fine. So we'll have to move along to the next value. So 3 goes into 10 3 times. So that gives us 9. 1 and 3 doesn't, then we bring down the 0, and then 3 goes into 10 again 3 times, which gives us 9. 1. So the answer is 33 remainder 1, which means that if I wanted to write, actually let me pop over to code now. So in Python, if I wrote 100 divided by 3 with a single division sign, it's going to tell me 33.33333. So this is doing floating point math. If I say what is 100 divided by 3 with integer division, it's going to tell me 33. If I want to know what the remainder is, I use the modulus operator. The modulus is what is the remainder you would get by dividing 100 by 3. And the answer in this case would be 1. And so I'd suggest, do a few examples of long division, pick some different numbers and say, what is this divided by that? And get different answers of something, remainder, something. And then check it out. Try it. Open a Python interpreter and say, this number integer divides by this, and it should give you the dividend quotient. And this number modulo that number should give you whatever remainder you found, and then see if, and that's an opportunity to double check your long division. Okay, so hopefully that's helpful. Let's see. Someone says, I uploaded my file for exercise 1, 7 tests succeeded and 3 failed. So if you're not sure why some tests succeeded or failed, do feel free to send me an email and I can check on it. Yeah, I will say that I may have to rework that auto grader slightly to give you a grade of either 1 or 0, because again, the exercises, you're only supposed to be graded on doing them and not on correctness, so I may have to tweak that a little bit. Yeah, but do send me email and I'd be very happy to chat with you. Also, I note that a few people did email me through Brightspace, through the D2L mail. I will try to check that sometimes, but you're much more likely to get a prompt response from me if you send an email to my actual email. So jonathan.anderson@mun.ca. There's a question in the grade book, got 0 to 3 in correctness about the computers around you question. Yes, so I haven't finished grading that question, and so nobody should have a 0 on the correctness of that. So if you see a 0, that probably just means I haven't graded your answer yet. I'm quite surprised that Top Hat presents it as 0 out of 3 and not so when I look at it in the grade book, I see somebody who submitted got 2 out of 5 on completion because they uploaded anything, and dash out of 3 for correctness if I haven't graded it yet. Sorry that you're seeing 0. Don't panic. Nobody should be getting a 0 on the correctness. It just means I haven't finished grading your question yet. I've done some, but not all of them. Question, is there a leaderboard for assignment 1? No, there isn't one for assignment 1. Okay, so at this point, I should probably, someone says, where's the assignment document? So I should also say it's not an assignment. This is an exercise. Assignments will come later, and assignments have different rules, like you're not allowed to work on them together and stuff. But on the course website, if you go to exercises, you should see exercise 0, and now you should see exercise 1. All right, well, at this point, I should head off, but it was very nice to chat with you all, and I hope you have a lovely rest of your day. And a couple of people came by the lab yesterday to check out their equipment and make sure it works, and also just to say hi to the lab instructor, and that's lovely. For people who are scheduled in the lab tomorrow or Friday, if you'd like to do that, that is also definitely an option, and we'd be very happy to actually see students. That's very nice. We like students, and we'd love to see you, but also maybe we'll just see you next week, and that's also fine. So hope you have a great rest of your day, and see you virtually on Friday.